Hello everyone, welcome to this class. In this class, we're going to deal with complement of sets. The complement of a set is a set which contains all the elements in the universal set which are not in the set. Let's look at it this way. You have a universal set and you have set A. Now you're going to look for the complement of set A. Now this is okay, I'll come back to that. It simply means any element that is a universal set that is not in set A, that's a complement. Complement as an English term, even they define it, a complement is something that makes something complete. So a set that you need to add to this set, it completes what you have in universal set. That is the complement of set. So we have this notation to denote it. Whenever you see a set that has this apostrophe, simply means complement of the real set. So let's go to example 2. We have universal set 1, 2, 3, 4, 5. We have set A 1 and 3, and then we have set B 3 and 4. Now I've been told to look for number 1 is A complement. So let's go. A complement simply means what do we have in A, in universal set that are not in A. So this is A 1 and 3. So the A complement will simply be, we have 1 is there, 2 is not there, so we write 2, 3 is there already, 4 is not there, right? 4, and then 5. This is the complement of set A. The second one says complement of set B. What do you have in B, in universal set that is not in B? So let's start. 1 is not in B, so write out 1. 2 is not in B, so write out 2. 3 is there. 4 is in B. 5 is not in B, so write out 5. This is the complement of set B. This is 2, 4, and 5. So this is now 1, 2, and 5. This is a complement of what? Set B. So we now have A intersection B complement. First, you have to solve for the A intersection B. So A intersection B. First, that's all. Okay, complement. This is a question. So first thing you solve is A intersection B. This is B. This is A. This is B. What does A and B have in common? They only have 3 in common. So A intersection B is 3. So A intersection B complement will now be what you have in universal set that is not in this A intersection B. So we have the first one, 1, 2, 3 is here, so we don't put 3, 4, and then 5. That's A intersection B complement. Then the next question is A union B complement. Let's go to D. A union B or complement. First, let's for A union B. A union B. Remember what I said, union is combining the two sets or the three sets, depending on how many number of sets, without repeating anyone. So we have A. Let's go to A as, let's start. A is 1, then 3. Let's go to B. 3 is already there, so we're not repeating it. Then 4. This is A union B. So the complement of A union B we are now going to go to the universal set. 1 is here, so we're not putting it. 2 is not here, so we'll put it. 3 is here, so we're not putting it. 4 is here, we're not putting it. 5 is not here, so these are your answer for A union B. Let's go to the next example. So let's go to example 3. This example 3 is a very tactical one, so we have to pay a very deep attention to it. We have a universal set. It is the set of all cars. So we have this universal set like this to be the what? All cars. So we also now have R is the set of all red cars. We have R, set of what? Red cars. Then we have F is the set of all cars with 4 doors. We now have F. I will also write cars with 4 doors. Now show on a Venn diagram the set of all red cars which do not have 4 doors. Be a very big example. we have all cars as this, we have R as red cars, and we now have F as cars with 4 doors. Now we are being told to look for on the Venn diagram red cars which do not have 4 doors. So we have red cars without 4 doors. So using our common sense here, we already know that if F stands for cars with 4 doors, now we're looking for cars. Okay, sorry, this is without. Sorry, we're looking for cars that does not have 4 doors. Now, for us to get car does not have 4 doors, I can say cars without 4 doors simply means F complement, because F stands for all the cars with 4 doors. Any car that does not have 4 doors is a complement of F as regards to what the universal set. The universal set is all cars. That has been established. Now, we are being told to look for the red cars that does not have 4 doors. So red cars without 4 doors will simply be R intersection F complement. I don't know if this is confusing. This F complement stands for all the cars without 4 doors. Now, inside this red car, this is R stands for all the red car, but inside this red car, you know that some of them will have 4 doors, while some will not have 4 doors. But we are more interested from our question, all the red cars without 4 doors. So all we are going to do is look for the complement of F, which will now tell us all the cars without 4 doors. Then all the cars without 4 doors, intersection of R, intersecting R, which is all the red cars. When you intersect all cars without 4 doors with R, it will only give you all the red cars without 4 doors and leave out the red cars that has 4 doors. Like when you say R, simply means, let's say the red cars with 4 doors are 1, 2, and 3. And F complement, red cars without 4 doors. F complement is cars without 4 doors are like 1, 6, and 7. So when you do the intersection, you see that you are going to capture this one, which is this car does not have 4 doors and is also red in color. I hope we understand the logic. So this is what we are going to draw in the Venn diagram. So first, let's do a rough sketch as we used to do. We are trying to establish this. So this is what we are going to do. And this is for our universal set. So I can, then we already know we're looking for R intersection F. So let's say this is R, which is red cars, and this is F. F. F stands for cars with 4 doors, right? Cars with 4 doors. Now what we are trying to get is this R intersection F, which is just this. No, this R complement, sorry, F complement, I need to say. So I'm going to explain it. F complement intersection R. Now, because this is a universal set, let's assume, and this is universal set, so the complement of F will be everything outside this circle. This is circle that represents F. So its complement is everything outside this circle. Hope you are getting. So let's say that all the red cars are represented by a horizontal line. Let me draw a horizontal line. And let's say all the cars that has 4 doors are represented by no shading. So this will be no shading. All together. So I'm not going to shade anything in F. Here now, this is intersection of R and F, which is red cars with 4 doors. So this is the intersection. So that's why this horizontal line cross here, because horizontal line represents R. Now next thing we are going to do is let's the vertical line represent our universal set, or let's say F complement. Let vertical line represent our F complement. So let's do like this, F complement. I don't know if, since it's F complement, we are not going to touch inside here. So inside here will remain blank. Now, This vertical line stands for what? F complement. That what is not in this F. So from our Venn diagram, what we are looking for is R intersection F complement. So this is it for us. Where this R intersect this. So this is it. Just this circle that has more here chopped off, because inside this intersection of R and F, we also have a car with 4 doors, so we are avoiding it. So our answer is simply where we have horizontal and vertical line crossing, and is only inside this place. Here is only horizontal and vertical line alone, which represent all cars without 4 doors. But here is both horizontal and vertical, which means all cars without 4 doors that are also red in color. I just hope we understand this. So let's go to our exercise classes. So go to exercise 8B. We have our universal set as A, B, C, D, E, our A as A, C, E, and our B as B, E. List the members of the following set. A complement, let's start. A complement is what we have in A. What we have in universal set that is not in A. So let's go. A is there in A, B is not there. So write out B. C is there. D is not there. So write out D. E is there. So this is our answer. Put in the second one, B complement. What we have in B, universal set that is not in B. A is not there. B is there. C is not there. D is not there. E is there. So this is our answer. Go to number C. A complement union B. This is our A complement already here. So union B. This is our B. So A complement union B. So union is both of them without repetition. This is our A complement. So I can write B, T. So where is my B? This is my B. B is already here, so I'm not repeating it. E is not here, so I write E. Is my answer. Next one. Number D. A union B complement. A union B complement. So this is A here. This is B complement. So let me write out A, C, and E. A, then B complement. A is here, so no repetition. C is here, so no repetition. D is not here, so I'll write it out. D. The next one, which is E. A complement intersection B. A complement. This is my A complement intersection B. So what does B and A complement have in common? Is only B. So we'll write it out. B. Number F. A intersection B complement. Seriously? I think I've done that before. Okay, I haven't. A intersection B complement. This is my A. This is my B complement. So what do you have in common? They have A in common. Do you have any other thing in common? You also have C in common. So the next one is number G. A complement union A. Mind you, let me give you this hint. Any complement and its union will give you a universal set. This will simply give us our universal set. I don't know, I'm having issue writing this universal set symbol, because the complement is simply the number in the universal set that is not in A. So when you combine number that is in universal that is not in A plus number in A, it will give you total universal sets. I will solve for this one, but the rest I will not. So let's go for it. A, we have A, C, and E, right? Then A complement, we have B and D. So if you check, A is here, B is here, C is here, D is here, E is here. Mind you, instead the order of arrangement does not matter. So this and this are the same, but you can rearrange it to give you this. So you can notice that this is still the same as the universal. So let me try if I can draw it well this time around. So that's it. Let's go to the next question. H. B intersection B complement. B intersection B complement. Mind you, any complement of a number intersection that number will give you an empty set. P is the symbol of an empty set, or you use this symbol without putting anything inside. Mind you, because the complement is simply what the other one is lacking, so there is no going to be anything in common. So let's solve it. This is B complement, and this is B. You can see BE, ACE, they don't have anything in common, so it's an empty set. Let's go to the next question. I say A union B or complement. So A union B or complement. First and foremost, let's look for A union B. A union B is A and B combined with a repetition. Remember? So this is A. I'll first write A, C, and E. This is B. B is not here, so I'll write B. Then E is here, so no need to repeat it again. So the complement of this. So you're looking for what does the universal set has that this does not have. So let's go. A, it has it. B, it has it. C, it has it. D, does not have D. E, it has D. So A union B complement is now just D. Next question is J. A complement union B complement. A complement union B complement. This is A complement. This is B complement. So to find the union, let me write out for A. We have B and D. Then go for the B complement and add. A is not here, so I can write A. C is not here, so I can write C. D is here, so no need to repeat it. So this is the answer. The next one is K. Let me write K here. K says A intersection B or complement. A intersection B complement. So what is A intersection B? This is A and this is B. What does A and B have in common? So A intersection B is, I don't think they have anything in common. This is A is not here, C is not here, E. Okay, they have E in common. So this is E. So the complement is, what does universal set have that this does not have? Let's go to universal set. Let's go to A intersection B complement. Universal set has A, so have A. It has B, have B. It has C, it has D. Then E is already here, so we're not putting it. So this is your answer. Then the final question is L, which is A complement intersection B complement. This is A complement, this is B complement. So what does this and this have in common? They only have D in common, so you have T. So this is it for this class. Any question, drop in comment section. Thank you and see you in the next class.